Hey class, we got a short one today. We are going to look at a couple integration techniques as well as Riemann sums and call it a day from there. So the first one here, this is a problem right off the old AP exam. It asks us for the value of the left Riemann sum approximation for the integral from 0 to 50. So Riemann sum, remember, we are setting up rectangles. So area of a rectangle is base times height. So for the base, so I've got the point 0.04 and the point 25.6. So we create our rectangle with the leftmost point. So that first rectangle is going to look like that. So its area is going to be 25 units times whatever the left point is. So 25 times 4. And then the next one has a base of 5 units times 6. And then we've got 20 units times 8. Looks like 290. Number 23 defines f of x as the integral from 4 to x squared of root t dt. To find the derivative of an integral like this, we take the x squared and we plug it in for t. So we get square root of x squared. And then we need to multiply by the derivative of whatever we plugged in. X squared is correct. Number 3 here. Number 3 asks for the integral of x squared times the quantity x cubed plus 5 to the 6th dx. It's not something we can integrate as is because we're multiplying here. We also have something other than just x to the 6th. We don't want to expand this. We want to u substitute, make u equal to x cubed plus 5. So du would be the derivative of this, which is 3x squared times dx. So to get my du, I need 3x squared dx. I've got x squared dx, so I need to multiply by 3 so I can replace all that with du. But I also need to multiply by 1/3 to cancel out that 3 that I multiplied by. So when I rewrite this in terms of u, I've got 1/3 times the integral 3x squared dx becomes du, and here I have u to the 6th. When we integrate to an exponent, we add 1 to the exponent and divide by that same thing. So I get 1/21 times u, which is x cubed plus 5, to the 7th plus c. Looks like e. Number 22 asks for the horizontal asymptotes. To get horizontal asymptotes, you can either remember the rule, which the rule is we look at the degree on the top, 1, and the degree on the bottom, square root of x squared, so 1. When they're the same, we divide the leading coefficients. 2 divided by square root of 1. So 2. Y equals 2 is a horizontal asymptote. The tricky thing is when you have this square root here, it will always result in a plus or minus because this is the one time when you approach negative infinity that it turns out different. So the answer is going to be D. Y equals 2 and y equals -2. Basically, as we approach positive infinity, it's going to 2. And as we approach negative infinity, it's going to -2. So you can have two different horizontal asymptotes. And the last example here, I know it says example 1. Asks us for the integral of 6 minus 4x over x squared minus 3x plus 3. Let's use substitute, make u equal to the bottom. So my du is 2x minus 3. We don't have 2x minus 3 here. At least not yet. If we take out a negative 2, now we have negative 3 plus 2x minus 3. So the 2x minus 3 is already built in there. My du is 2x minus 3 dx. I've got 2x minus 3 dx right here. So when we rewrite in terms of u, it's going to say negative 2 over u. This becomes du. The integral of 1 over u is natural log of the absolute value of u. And then we can replace. That's it.